Hello students, my name is Dr. Kollolini Banerjee and I'm going to discuss on the paper VLSI Design Automation. So for a good VLSI design, there are some points I will discuss right now. So besides realizing the desired specifications, a good VLSI design must satisfy the following criteria or the following entities need to be optimized. So the first point is area. Minimization of chip area is important to reduce the consumption of wafer area and to increase the yield of the design of the chip. Now, what does this yield mean? Suppose if there are 100 chips which is fabricated, then how many of them are good is known as yield. Okay, so that is very important term in VLSI designing, and minimization of chip area is very important. The next point is speed. So we always need higher speed of operation, so the speed of a circuit needs to be increased. However, increasing the speed increases the chip area as well. So, minimization of chip area and increment of speed needs good care of the design and need a trade-off between these 2 points. So, we need proper optimization. Okay. The third point we have power dissipation. If a chip dissipates too much power, it becomes too hot and ceases working or need extra or some expensive cooling mechanism, which in turn enhances the cost. So reducing the power dissipation often very important. Okay, it becomes very important, but due to this reduction of power dissipation, there will be some reduction in speed as well. So there is an optimization between speed and power dissipation as well. Okay. The fourth point, we have design time. The design time of an integrated circuit needs to be small so that it is available at the market at the earliest for the economic reason. Very obviously. Okay. So it should be as early as possible. We should make it commercial. The fifth and the last point, it should be testability. It is important that a chip is testable because the best equipment and the testing process is often very complex. So with this, we can sum up that for a good VLSI design, we need all of them, and a good optimization is needed for achieving a good VLSI design. Okay, so the next topic I will discuss design domain, and this one is another very important topic from your semester perspective. This is known as Y chart as well. Okay, Jaski's Y chart. So we have 3 domains here: structural domain, behavioral domain, and the last one is geometric layout domain or physical domain. So the VLSI design process is described in these 3 domains, and these axes are actually shown like Y, and that is why this chart is known as Y chart. So let me discuss on the 3 domains one by one. First, I am discussing the behavioral domain. In this domain, the part of the design or whole is seen as a black box. Okay. The relation between the inputs and outputs are given without reference to the implementation of the relation. Okay. In this behavioral domain, we have algorithm, finite state machine, module description is there. Okay. And other points are also there. So the transfer function can be there, register transfer can be there. And the next is structural domain. In this domain, the circuit is described by a set of sub-circuits. Okay, a bigger circuit is described by a set of sub-circuits and the interconnection between them. And in this structural domain, we have processor, register or ALU, okay, ALU or like RAM, the memory units, leaf cell, and the basic cell is the transistor. Okay, so the abstraction level is from the outer, each axis represent a design domain, and the level of abstraction actually decreases from outside to the center. So level of abstraction decreases from this outside to the center. The last domain is the geometric layout domain or physical domain, and this domain deals with the actual geometry of the circuit and describes the shape, size and location of the components. And here we have mask, cell placement, module placement, chip floor plan, etc. Actually, in this domain, the level of abstraction is from mask, it is cell placement, next module placement. So with that, two different points we need to discuss, that is the design methodologies. Okay, the design methodologies of these three domains. There are actually two basic types of design methodologies in VLSI. One is top down design methodology, another is bottom up design methodology. In the top down design methodology, the top level blocks are defined and identified. Next, it is decomposed in the sub blocks. Okay, I'm just showing it into the diagram in the next slide. And in the bottom up design methodology, it is actually reconstruction kind of thing. So identify building block that are available for us, build a bigger cell using this block. So we are reconstructing here. Continue build a cell until we build top level. A combination of top down and bottom up design are used in today's digital design. Okay, so let me just show you this figure where it is top-down design methodology. Here, in top-down design decomposition, the components with known behavior are decomposed, are decomposed into smaller blocks, which is here written as sub-blocks, with simpler behavior and an interconnection structure. Okay, this corresponds to transition from behavioral and structural domain. Okay, so in this Y chart, the behavioral and structural domain follows top-down design methodology. Each subcomponent is again located on the behavioral axis, and this decomposed in its own turn. Again, it is decomposed in leaf cells. Okay, and this process continues until a sufficiently low level of abstraction is reached, and this sufficiently low abstraction is here the leaf cells in the figure. When a circuit is fully specified down to the lowest structural level, the layout is specified in the bottom up design methodology. Basically, the geometric layout domain is following this bottom up design methodology, where the transistors are grouped to form cells. This is macro cells, and cells are grouped to form the modules, that is the top level block. So with this, we have completed this topic, that is the Y chart. It is as well very important for your semester examination, and the design methodologies are also covered in this presentation. Thank you.